All right, good morning, everyone. Today is Wednesday, March the 9th. We are doing, I guess, more 404 problems. So keep in mind that on the schedule, I just had it open. We were supposed to do 4.04 day, I think day 2 lesson. However, we actually had the lesson on the 2nd. So if you're watching this recording and you have not watched March 2nd's recording, you need to watch that because that's the actual lesson, 4.04, day 2. Today we'll be going over a couple examples. First one being the bell work, which is actually TGA number 2, just, well, different numbers and whatever, but same type of problem. And then we'll be doing some problems from yesterday that we didn't get to that are good. All right, so Noah says there's 6 solutions. Noah, shh, quit giving it away. There is 6 solutions, yeah. The people that found 2 solutions, what 2 did you find? Let's see if at least those 2 are correct. Be brave. It's okay to be wrong. So Enzo, we got 7 pi over 36 and 11 pi over 36. 7 pi over 30. Yeah, okay. Yeah, so those 2 are correct. Those are 2 of the 6 solutions. Now, Enzo, it sounds like you did the problem correctly, but what you didn't do is you didn't check other possibilities. And what I mean by that is, Enzo, at the step that you're at, you need to make n equals 0, n equals 1, n equals 2, and so on to see which solutions lie between 0 and pi. You keep going up by n until your range of solutions fall outside that range. Does that make sense? And it doesn't take a while because you type in the first one and then you just hit the back arrow and change your n value from 0 to 1, then from 1 to 2. You just keep changing it, hit enter, change it, hit enter. On your paper, you got to write n equals 1, 2, 3, 4, 5, or whatever, but then you just type it and hit enter. You don't have to show the setup. Yeah, that would take a while. Yeah, it takes an extra, 30 seconds to find other values? Okay. All right. So I'm guessing everyone else needs to see this work and the explanation, right? Okay. So these problems are in the module, and maybe just haven't got to them yet because we technically didn't do it until yesterday, I guess, even though we did it last week. And but it's repeat week for Tuesday, Wednesday, Thursday. All right, so it says, what are the solutions of the equation cosecant 6x equals -2 on the interval 0 to pi? So we're going to use, so day 1 of 404 was the general form. And when you have an answer, then you have like plus like 2 pi n or pi n, depending on if it's tangent, cotangent, or something else. So this is similar, but now we're on a domain, or sorry, basically an interval restraint from 0 to pi. All right, let's take a look. All right, how did all of you solve this? Take me through that, everyone. Let's kind of be, let's participate. So remember, Enzo, not everyone has an arc cosecant on their calculator, so we probably can't really do that unless you have like an Inspire or something. But you're not wrong, Enzo. You're not wrong at all. But let's do it the non-TI Inspire way. All right, so we want to make cosecant 1 over sine. Exactly. So let's rewrite cosecant 6x as 1 over sine 6x. All right, all right. Everyone's paying attention, right? A lot of people are tabbed out. Guys, if you're going to tab out and you're not going to be here, just watch the recording later. Just hold everyone else up. All right, what's our next step? Yeah, I do that little math trick, right? The diagonals. Another trick we can do is we can take our fraction and we can actually flip it upside down both sides. That's another little trick. So that -2 is over 1. So we could just flip both sides upside down, which is the same thing, really, of the math trick, right? Or you can just swap diagonals. So whenever you have a fraction equals a fraction, you can trade places with diagonals, or you can take the entire fraction both sides and flip it upside down. So that's those are the two math tricks. All right, then what? Yeah, we're gonna arc sine both sides. Sure. And I think I just reordered mine. I put my sign. Oh, okay. I did that first. I just moved the sign to the left and the -1/2 to the right. Um, and then I arc sine both sides. All right. So on your unit circle, what is arc sine of -1/2 equal to? And yes, you have to use your unit circle. If you use your calculator, you only get one solution. All right, we got 7 pi over 6, 11 pi over 6. All right, so what's our next step? Wrong. So we did have a lesson on this, and I did teach this. So let's see if we remember how to do it. You would think you would want to either divide by 6 or multiply by 1 over 6, but that would be incorrect. We could add 2 pi n to both solutions. Yep. Yeah, you want to do what Enzo says, and you want to separate the equations, right? We have 6x equals your first answer plus 2 pi n, and then the other one. So does this look familiar from the lesson we had on it? It's from 4.04 day 1. I believe it was day 1. Yeah, it was, right? Yeah, I think. It's all coming back to us. So this is the step that a lot of people forget because a lot of you just want to separate them without having the 2 pi n, but we have to write it for the general equation before messing with the 6. Why is it plus 2 pi n and not plus pi n? Or in other words, when will we have to write plus pi n at the end? Yeah, when it's tangent or cotangent. Those are only times we have to write plus pi n instead of, well, plus 2 pi n. All right. Now from this step, what can we do to both sides? You can either divide everything by 6 or multiply everything by 1 over 6. Me personally, I like looking at it as multiplying everything by 1 over 6, because then that way you can at least do it in your head. Dividing a fraction by another number, you have to kind of write it down, and you got to flip and multiply, and well, that's no fun. All right, so the first one, multiply by 1 over 6. So we get x equals, what does 7 pi over 6 become? 7 pi over 36. And then what does 2 pi n become? pi n divided by 3. Yeah. And then we do the same thing to the other one. Okay. All right, so this right here, I guess you want to call this maybe the part one of this problem. This is, so these answers that we have, this one and this one, what are these called? What are these answers called? They're exact, yes, but they're general solutions. General solutions have the plus whatever n term. That's a general solution. Oh, did I forget to type in pi? Oh, I did. Whoops. Let me fix that. I typed this yesterday. You guys want to see how I format some stuff? Let me show you kind of a, I don't know. Some of you try to type in Word or whatever, and your formatting isn't that great usually. Let me just show you if you're kind of curious. So let me share my, let's see, PowerPoint. All right, here we go. So I've learned a lot of, I guess, shortcuts or whatever. But like for this one, I forgot to put the pi there, right? Some of you might think, all right, well, you just put your cursor there, then go up to equation, and then you can find it in this mess. Well, yeah, you're correct, but there's an easy way to do it. You just do a backslash pi space, and then boom, it does that. How cool is that? We can even do like backslash bullet space. Look at that. See, so much easier. And that's if you ever use the equation editor. There are shortcuts to make equations. Yeah, anyway. But yeah, there is a pi in front. Hopefully it's probably going to be the same way in the next page because I probably just copied and pasted it. I don't remember. We'll see. Or I could copy it, you're right. All right, next page. Not quite done yet. Oh, yep, I just copied and pasted. This is, yeah, so it shows that I actually don't use what I put on the screen to do my math. But yeah, that should be a pi n. All right, so next, when you do these types of problems and you want to find the solutions on this interval, remember, n can be anything from negative, 0, positive integers. But for these, we're going to start at 0. If you do go negative, it will actually put it in quadrant 4, which is outside this range, or this interval, sorry. So we start at n equals 0. And all we're going to do is we're going to plug in 0 for n and solve. And that was pretty easy, right? Anything times 0 is 0, right? So that first answer is 7 pi over 36. Now, these should be pretty easy to determine if it's in quadrant 1 or quadrant 2 from 0 to pi, right? 0 to pi is the top half unit circle. All you got to do is look at this fraction. If your number is greater than 1, well, let's that would be past pi. So is 7 over 36, is that between 0 and pi? It sure is. So there is one of the many answers. Next, we're going to go and we're going to plug in n equals 1 into the equation. And all you got to do is just hit the back arrow on your calculator and change n from 0 to n equals 1. Everyone do that and then hit enter, and what do you get? We got 19 pi over 36. That sounds right. Is that answer between 0 and pi? It sure is. So there's another answer. All right, and now let's go to the next one. Let's do n equals 2. All right, so hit the back arrow on your calculator and change the 1 to a 2 and hit enter. What do you get? 31 pi over 36. Yep, is that number between 0 and pi? Sure is. Yep, 31 over 36 is less than 1 and greater than 0. So, yep. Then we go to n equals 3. And everyone hit the back arrow on your calculator screen and change that from a 2 to a 3. And what do you get? We get 43 pi over 36. Is that between 0 and pi? Nope. Nope. So that is a no. So guys, on your TGA for this is number 2 on your TGA. I need to see all of this written out. And then I need to see the ones that do work. And then I need to see the one that doesn't work. If you just give me the answer and I don't see the work that you tested, because you keep going until you find one that's outside the interval. If you don't have that, I will mark it wrong. Because how do you know when to stop, really, right? Yeah, you put smiley faces. Absolutely. That, I don't know, this is a visual indicator saying it works, it works, it works, it doesn't work. So any work that I show on doing problems, you're more than welcome to kind of do the same format. It's just like if you were to look at my work, you, assuming you're in this class, right, you would understand what that means when talking about this equation on this interval here. All right, so we got those. Once you get a sad face, one doesn't work, then we stop. So here are 3 of the 6 solutions. All right, so we are going to plug in the first one, and obviously it's 11 pi over 6, and that is definitely between 0 and pi. All right. All right, now let's change that 0 to a 1, and what do we get? 23 pi over 36. Is that between 0 and pi? It sure is, yep. All right, now let's type in n equals 2. And what do we get? 35 pi over 36. All right, is that one in the interval? It is. It's very close, yeah. And then we have to check n equals 3. Remember, we don't stop until we find one that doesn't work. All right, and what is that? Does that one work? No. Yeah. Which so Brady, answer your question. Which model do you have again? Do you have that TI-30? Is that what you have? Yeah. Uh, yeah. So if you, I'm guessing your TI-30 gives you a decimal, doesn't it? Yep. So you're gonna have to do it by hand, or spend a few bucks and get a FX 115 or FX 300. It is worth the like what $12, $13 for that calculator. Definitely worth it. Um, what is Enzo? What does CAS stand for again? I forget. Computer algebra system. I think it does. Yeah, it can solve equations too. I just haven't used it for that. There's a lot of features that I are on it that I don't use. Would omitting pi help? Then just put pi at the end. Yeah, probably. Yeah. Brady. So type these in without pi in there. That's a good point. Do 11 over 36 plus, well, in this case, 3 over 3. And then you should have a 2 fraction button on your TI. Okay, so that's a mixed fraction. We don't use mixed fractions in this class. I see mixed fractions. Oh, I cringe. People are still submitting TGAs with mixed numbers, and I'm like, where have you been this entire semester? So do it again. So hit the 2 fraction button. There is a way to convert it into a mixed an improper fraction instead of a mixed number. I know, dude. Those those mixed numbers trigger me. Yep. It tells me that you're copying from somewhere, or I don't know. I don't know. I don't get it. Did you figure it out, Brady? Just go to like YouTube or Google and say put in your model number and put convert to fraction, and then it'll tell you how. Yeah, we're good. Okay. All right. So we want to write all of these answers, preferably from least to greatest. Should be pretty easy because they're all over 36. And you just look at the top 7, 11, 19, 23, 31, 35, and then don't write these two because they don't work. So please write them in order, least to greatest. It just helps me grade them on your TGA when I look at them all. But yeah, those are solutions, and they all fall on the interval 0 to pi. And then we can also check these. We can type these into the original problem for x, and then hit enter to secant -2. We'll probably have to convert cosecant to 1 over sine 6x, but when you do that, you can type it into x right here, all your answers, and hit enter, and you'll get -2 every single time. It's pretty neat to verify. Also, on this next page, I graphed all 6 solutions to show that they are on the interval from 0 to pi. And I made this graph in Desmos. All the ones that are, I guess, this blue color, This is, I think, the first equation, and then the ones that are green are from the second equation. I don't know. What color is this? Is this yellow? You see purple and orange. Okay, whatever. Purple and orange. Purple and orange. I don't know. If we're adding 2 pi each time, so we're not adding 2 pi. What we're doing, now that's part of the work. We have to do this for the general equation before dealing with this 6, because the 6 was originally inside the parentheses. So this is the cosecant of 6x. And that's just how you deal. That's how you deal with when you have a coefficient inside the parentheses. Yeah, so we're actually adding only pi over 3 every single time. Yeah. Let me send you the link. I have the link to, if you really want to curious how I graph this.
I have a question. So couldn't we know, like, for the other one, 3 was our denominator?
Actually, before I show you this link, how do you think you graph this point? If you wanted to do 7 pi over 36, how would you graph that coordinate? You would, yeah, in Desmos. I know that, Brady. But in Desmos, how would you type it in? Let's be a little specific here. So we know the answer is 7 pi over 36, correct? That's one of the solutions. Now, looking at the unit circle, I'm trying to push you in the right direction. Let's, everyone, well, we don't have 7 pi over 36. So let's look at a basic one. Let's look at pi over 6. We can see the coordinate is rad 3 over 2, comma 1/2, right? Now, if I guess algebraically, how would, if I just gave you the angle pi over 6, how would I notate I want you to give me the x value as the answer? What would you do? You know the angle is pi over 6. How do I know I want you to give me the x value in a problem? Cosine, yeah. So if I want the x value, you would tell me it's cosine of pi over 6. And then how would you give me the y value if I gave you the angle of pi over 6? Yeah, I would say sine of pi over 6. So it's just a coordinate, x comma y. So I'm going to type it in chat. So couldn't I just write that as the coordinate? Cosine pi over 6 comma sine pi over 6. Doesn't that make sense a little bit? Yeah, and that's exactly how you do it. Yeah, so let me go ahead and link this Desmos for you, and you can see I used a table because that was I used a table that way it would draw a line from the origin to the actual coordinate. So when you actually open it up, and then I did the arch. We learned how to we learned about circles last semester. So I graph the equation of a circle with a radius of 1. But I have a range restriction from 0 to 1. So it would only graph the top half of the circle. So when you're looking at my equations I put in. You know, I know a thing or two. All right. Well, fun stuff. So this should help you tremendously on your TGA number 2, right? And when you show me your work, I need to see this work. I need to see the work set up for n equals 0 and up until it doesn't work. And then you write the answers from least to greatest, preferably. You don't have to graph it. What's your question, Noah?
So I looked at how they solved this problem in the OHS, and what they did was they substituted 6x for theta to solve it first, and then after they had the general solution, they put 6x back to where theta was. Would that be an acceptable way to do it? I mean, like, it's kind of
Hold on.
harder, but
Hold on. I think my sound's not coming through my speakers. Sorry. Let me. All right. Say it again. Sorry.
okay. So I looked at how to do this question in the module, and what they did was that they substituted 6x for theta for like the first part of the problem to solve for theta, and then after they found the general solution, they substituted 6x back into theta. Would that be an acceptable way to do it on the TGA?
It is, but so let me go back. I'm just going to re-say what you just said with pointing the stuff. So in the module, they replace 6x with just theta. That way you're not actually looking at the 6. And they do everything the same, and then they'll have theta equals these 2. And then they put the 6x back into it. Yes, you can. I don't really see the point because to me, it's seeing 6x is not a really big distractor. That would make me want to do that extra step. If you want to, you can. You see what I mean? I don't know. It's really up to you. It's funny how the module will show little things like that, but on other problems, when there's like big steps from one step to another, they totally skip it and they just assume you know what's going on. I don't know. I just find that kind of odd. Yeah, and like Enzo says, you might even forget to change it back. Yeah, there's always that too. Yeah, that's a good question. It's really up to you. Did the module, other than that, did the module kind of take you through the problem similar to this, I guess? I haven't looked at it in a while. All right, let's look at some more examples. Not one like this, though. All right, so yesterday we went through this one together. So we did finish that yesterday, and so we have. I want to do 2 more. Number 23 and 24. Yep, 23 and 24. All right, so I want everyone, if you haven't done this one already, please do it on your paper. I know all of you do have the answers and the work, but try doing this without looking at the work. Just give me a green check when you are ready to go through it. Off topic. Off topic. I get a news feed and big news for Arizona. Nestle is going to build a $675 million coffee creamer beverage factory in Glendale. That's exciting. That brings money to the city, to the states, jobs. Maybe they'll make chocolate there too. No, this is a factory. It's not a shop. It's a factory. It's where they're going to make it. You know, I'm not an economist, but I imagine when you have big companies building large factories in the area, it brings more people in, but also drives up the price of real estate. So if you're trying to sell a house, good. And if you're trying to buy a house, well, not so good because now it's even higher price. I know it's not like it's not already all-time high. Yeah, that's true. Yeah, I don't know how anybody affords to buy any house in Arizona right now or anywhere. It's kind of nuts. All right. What are the two answers for? Well, we know the two answers, right? Because we have the answer key. How did everyone do getting those two answers? Good, good. Not good. All right. Well, let's go through it. Divide by 4 both sides. Then we do the arctan both sides. and then you get your answer, right? And so the first answer is 1.404. So that is the first one, and we only convert it to degrees just to see which quadrant it's in. But really, you might want to, on your unit circle, label at the top of, I guess, each major, I guess, at 90 degrees, at 180, and then 270, the radians. So this is at the very top, 90 degrees is pi over 2. So pi over 2 converted into decimal, put that number at the very top of your unit circle. Pi is 3.14, and then this is what, 3 pi over 2. You want to type that in and then write that decimal equivalent. And then if you have those written down on unit circle, you can really avoid doing this, because then you can see that 1.404 is less than this number at the top here, or whatever you wrote. So we would know it's in quadrant 1. Really up to you, though. Well, see, for any problem, you shouldn't be looking at one problem to try to solve the other one. It's a really bad way to do math, because you're not learning how to do the math. You're just learning to try to find a problem that looks like that problem and just try to duplicate the work without understanding what's going on. It's a horrible way to do math. Every problem should be unique, and you should treat it as such. And you should understand on how to approach these. Now, if you need to look at a problem to kind of refresh yourself on what's supposed to happen, sure. All right, so 1.404 is the one solution, and then next we want to create that diagram. It really helps. So over here, I have some stuff already pre-written down, but this represents our first answer at 1.404. And we look, remember, this is tangent. So tangent is y over x. So with tangent lines, they reflect diagonally. So this piece reflects from this piece and vice versa. So we just extend this line for our tangent solutions. And then we want to fill in some stuff. So this line right here, we know is 1.404 radians. So we're going to write that in. And then to find the other angle, what did all of you do? Well, you probably looked at my work, so you really know the answer. But we add pi to it. No, we shouldn't add pi to it. Or actually, yeah, we do. You're right. Because this angle right here that I'm highlighting is 1.404. This angle that I have highlighting in red, what's the radian measure of that? Yeah, that's pi. So I'm just going to write that's a measure of pi, and then this is a measure of 1.404. So yeah, we just add those two together. But using rounded work is bad. So instead of using 1.404, we should use the arctan of 5.95 in place of this. That we're using exact values and not rounded values in our work. Usually we get the same answer, right? In this case, we get the same answer, so it didn't hurt us if we use rounded work. All right, how does everyone feel about this problem? super good, I hope. All right, and then let's do our last one together. Number 24. Give me a green check when you have finished this one. And again, try to do this without looking at my work. And by the way, this problem is from our 4.04 day 1 lesson from Tuesday. And I did email everyone the PDF of this. All right, Simon, we still working? Okay. All right, so let's go through it. All right, we should subtract 2 both sides, then arc cosine both sides, and then we type it in, and we get 1.256. So this right here is the first answer. All right, so from here, what do you want to do once you have that first answer? Probably draw something. Yeah, it really helps, like a little rough sketch. Now, cosine represents which variable again? Yeah, the x's. So we want to know what is the angle in radians when the x value is 0.31. So the x value is positive. On the unit circle, the x value is positive in quadrant 1 and in quadrant 4. That's how I know to draw these 2 segments here to represent that. Yeah, x is positive. Very good. And then we can label stuff. So we know that this angle right here is what, 1.256 radians? And then we want to find, well, this measure, which is from here all the way around. And hopefully you figured it out without looking at the work. So how do I find, so what's, I guess, the math that we should use to find that angle? Yeah, it's 2 pi minus. So this angle right here, let me use a different color. I'll use green. I think it's green. I don't know. This right here is also the same. So in other words, we want to find a full rotation minus that little piece. And a full rotation is 2 pi. So that's why it's 2 pi minus 1.256. And for this problem, if you notice, if you use the rounded work, you get 5.027. But using the exact work, it's off by 1/1000th of a point. And I would gladly mark that wrong. Your module would gladly mark that wrong. So it doesn't happen often, but in this one, yes, there is a difference because rounded work is bad. All right. How are we all feeling? Good, I hope. All right, good. All right, and that's, of course, all the answers rounded to, I think, 2 places. Yeah, hundreds place. all the answers I did, we did 3 places. All right, everyone. Well, that's all I have time for. So as always, thanks for coming, and I hope you learned something. I will see all of you tomorrow, which is Thursday. All right. Have a good rest of your day.